So in your case,
So
you're given the leg.
it would be 7 square root 2.
Yes.
Okay. All right. Should I input that in the calculator or do I put it as that?
Yeah, so the way it says here, if the answer is 10 square root 5, it should be answered as 10 SQR 5.
So the answer would just be 7 square root 2.
Yes. 7 SQR2, apparently.
Mm-hmm. Right.
All right, so here is the next question that I see. This looks like number 2. Does that look right to you?
Mm-hmm.
So this time they're giving you the hypotenuse. The hypotenuse is the x root 2 side. So you have to look and decide, what are they giving me? What is known here? And this is known.
They're giving you the hypotenuse.
Exactly.
So the answer to those would actually just be 3, right? Because they're taking away the square root.
It's just the number this time.
Yeah.
All right, so I must have missed one here. So I did not get 3. 3 looks like it got cut off. Maybe it's in one of these other ones. So we'll just go to 4 here. All right, so the other type of special triangle that you'll see are these 30, 60, 90 triangles. And they too have a reference triangle that goes along with them. And then there's a relationship between all the sides. So the 30-degree angle is across from the smallest leg, or the short leg, as it's referred to. The 60-degree angle is across from the what's called the long leg. We'll get to that in a moment. The hypotenuse is double the short leg. So a lot of times students remember that double the short leg. The long leg is the short leg times the square root of 3.
Okay, so x would be 9 square root 3. Y would be 18.
Yes.
Okay.
And very important that you
I just got to remember the special triangles, and it'll just be easy. Okay.
Exactly. Yeah. There's no sort of shortcuts here. You got to know them all. There's 3. I found 3. Let me know when I can go back to 3. Is that good, Jacob, or can we move on to another question?
Yeah, it's good.
Okay. All right. The next one here is back to the 45, 45, 90. This is 3. So this time they're giving you the leg, both legs, and to get the hypotenuse, you take the leg and multiply by the square root of 2.
There'll be 4 square root 4.
Yes. And what does that reduce to?
2, and then it'll just be 8.
It is 8. Good. You got it. All right. So these are your 3. All right. So it looks like 5 is next. Yeah, 5 is next here. This one, you've got to find both x and y, just like number 4. All right, let's take a look here. So they're giving you the long leg. The long leg is across from the 60-degree. So the long leg, usually you start with the short leg. The short leg is x in the reference triangle. The hypotenuse is 2x, and the long leg is x root 3.
So I know X would be 3 then.
That's right.
And then I do 3 times 2, which would be 6.
You got it. Not too difficult at this point.
Pretty easy.
It all comes down to what they're giving you, and they're not really
I
being.
just remember the special triangles, and it's just easy.
All right, so I'll draw the reference triangle here again, but this time they're giving you the hypotenuse.
So they're giving me the doubled one.
Yes.
Oh, okay.
So you generally set the known side equal to the reference side and solve for X that way. And you got to be careful here because X in this case is the reference X. Really, X is the short leg. That's what you want to think of it as.
So would X be 6 square root 3?
It is, but in this problem, that's really Y because Y is across
Y.
from 30.
Okay, so Y would be 6 square root 3.
Yes.
And then X would be 6 square root 6.
Yes. No. I'm sorry. You take the short leg. Sorry, 6 squared 3 times square root of 3. It does work out nicely.
6 square root 9, which can be divided into 3. That'll be 18.
It would be 18. Perfect. Okay. All right, so it looks like 7 is the last one here
Okay.
of these.
Mhm.
Okay. There are harder problems here. These are maybe just getting you going.
Yeah.
Not sure. This one wants you to find 2 things, the altitude and the area. All right, so let's take a look here. The side length of an equilateral triangle is 8 centimeters. So here you go. Here's your equilateral triangle here.
8, 8, 8.
8, 8, and 8. Now, tell me about the angle in the equilateral triangle. Can you give me its
It will
numerical
all
value?
be the same.
And
then,
what is
right?
that? What is that same value?
90.
90 plus
Wait, no,
90 plus 90
plus
is 270.
270.
What do the 3 angles in a triangle add up to?
180.
180. So divide 180 by 3.
60.
60.
60.
So they're all 60, but I'm just going to draw the ones down here. When you drop an altitude down, it meets at a 90-degree angle. What does that make this angle up here at the top inside the triangle, smaller triangle?
30.
30. So notice it's a 30, 60, 90 triangle. And they're giving you the side is 8. Are they giving you the X, 2X, or X root 3 side?
X root 3 side.
X root 3 is
2X.
They're giving you the 2X side.
Yeah, so then I know that X would be 4, and then it would be X square root 3.
Okay, what is
4 square root 3, sorry.
4 square root 3? Good. So the altitude is the 4 SQR3. The altitude is the height. The area, and you got to be careful here because it's asking about the area of the big triangle here.
It's asking the area of the big one?
The big one. So your base
Okay,
is,
so then it would be 64, divide that in half, 32.
how did you come up with that?
Because I know I need to do 8 times 8 and then divide that in half.
It's base times
32.
height. The base is what it sits on, which is 8.
Oh, okay.
The height
So
is the altitude.
8 times 4 out of 3, 6, 9, 8, 6, 9, 12, 12, 6 square root 3.
Try again. You got 1/2 of 8 times 4.
Yeah, it'll be.
You only take half of one of the numbers.
Oh, okay. All right, it'll be 16 square root 3. Then.
Yes. All right, so let me pull up some other problems here. I don't want to hurt that one. All All right, give me just a moment here to get these put in front of you here. All right, so that's a good problem to have. All right, so here we go. Let me get you ready for another one.
Mm-hmm.
Okay, so the let's say the equilateral triangle has side length 2 square root 3. Okay, so I want you to find the value of h
Okay.
first. What is the value of h?
Just 2,
How did you come up with that?
because I know it's x times square root 3.
That's true, but they're giving you
Oh,
the
4. It would be 4.
So you
That
got to
right?
start. You got to start by identifying what are they giving you, which is the 2x side.
Oh, okay. All right. H will be 1 square root 3. 1 square root 3, but then 9.
Okay, so the this one is square root of this length down here is square root of 3. Do you agree with that? It's half the hypotenuse.
Mm-hmm. Yeah.
Okay, so if you multiply this by the square root of 3 to get h, what does that become? It's not 9.
Oh, just 3. Sorry.
Just 3.
I need to, because that goes into itself.
Okay. Next, tell me the perimeter of this big triangle.
Would I just add them? It would be
Just add up the 3
square root
sides.
3 plus square root 3. Square root 6. And then I know that one will be 9. And that'll just be 3, 6, 12, 18. Square root 18.
It's 2 square root 3 plus 2 square root 3 plus 2 square root 3.
Oh,
It's
perimeter. Okay.
perimeter, yeah.
2, 4, 6. 2, 4, 6 times 3, 6, 18.
You're adding though. You're just adding 2 plus 2 plus 2. Think of it as
Okay,
like 2x
6.
plus 2x plus 2x.
Oh, okay. All right. So just be 6 square root 3 then.
Or alternatively, it's 3 times the side length, which is 3 times 2 square root 3.
Mm-hmm.
Okay. All right. Now, last one here. What is the area of this triangle? The big one.
Okay. 6 square root 3 times 2 square root 3 times 3. 18.
So tell me how you came up with that. What did you multiply? 1/2. What's the base?
2 square root 3
Okay.
plus times 3.
Times 3. Okay. You can only multiply numbers outside the root.
Oh, so 6 square root 3 again.
1/2 times 2 is 1 times 3 is 3. You're only taking half
3.
of one of the numbers.
Oh, 3 square root 3.
Yes. Okay. Yeah, let me give you one more of these. Which one we do up here? We did that. Okay. So this one's a little bit easier here. I want you to find, let's say this is 6. I want you to find the value of h and then the area of this triangle, please. It's an equilateral triangle again.
All the sides the same, right?
Yes, all sides the same.
So the height would have to, so I do 6. So I know that one is the one that's doubled. No, that one's the one that, yeah, that one's the one that's doubled. So then I know it will, the bottom one will be 3, and I know the height will be 3 square root 3.
Okay, very good. Now give me the area, please.
3 times 3, 9 square root 3.
Very good. All right. So there's actually a formula here. Might as well give it to you now. So there's a known formula for the area of an equilateral triangle, and it's the square root of 3 divided by 4 times the side length squared. So this only works for equilateral triangles. Now, is it worth remembering? I couldn't say whether it is or not, but let's just look at it and see if it works for your problem up here. All right, so the side length of an equilateral triangle is 8 centimeters. That's S. Square root of 3 divided by 4 times 8 squared. 8 squared is 64. 64 divided by 4 is 16. Is that the answer you put for the area of this one?
Yes.
Yes.
Right.
So it works for that one. Does it work for this one that I gave you, which was the side length was 2 square root 3? Let's take a look at that one next. All right, so the area of a triangle is square root of 3 over 4. 2 square root 3 squared. When you square something like this inside parentheses, you square the 2 and square the square root of 3. So that's 2 squared times 3.
Plus,
4 times 3 is 12.
So
Notice you can divide 12 by 4,
and
that produces
so then 3
square root 3.
3 square root 3.
Now, is that what we got when we did it up here? It sure is.
Yes.
So is it worth remembering? I have no idea. You'll have to make up that decision on your own here.
Okay.
But something to think about when you're doing that. Okay, let's do another problem here. All right, so if the radius of the circle is 12, I want you to determine the area of the square first, please.
Radius circles 12. Radius is the half, right?
Yes, it goes from the center out. That's a radius.
Okay, so then I need to find the area of the square. Well, I know the radius will be the length of the square, right?
I would recommend drawing it to confirm what you're saying. You're making a little bit of a jump there that may not be true.
144.
Okay, how did you come up with that?
12 times 12.
Okay, well that would be true if the square, if this was the square, but that's not the square. Like what you did is you found the area of this square right here.
Oh, okay. I'm kind of confused.
Okay, have you drawn anything down on your paper there?
Yeah, I drew the circle and the square.
Okay, so here's a radius and here's another radius. What does that make up in the square?
Half.
Is there another word maybe that comes to mind?
Oh, that would be the hypotenuse, which would be the double of it, and then 24.
This is a 45, 45, 90 triangle.
Oh, 45, 45, 90. Okay, so then I know 12 will be the thing that is the one that is on the square root, right?
Okay, so that you're given the x root 2 sides. If you want me to go back, I can show you this here. This was the first ones that we did. That's the x root 2 side.
Yep.
So you essentially have to divide this by the square root of 2 to get the side.
Okay, so 24 divided by. Okay. 24 divided by the square root of 2. Okay. That will be by square root of,
So this ends up being 12 square root of 2.
yeah, 12.
And
I just need to put it like that. I don't need to make it, I don't need to have like the precise number.
Well, we do, this is the exact answer here. But
Oh,
that's not what we're
okay.
looking for. We're looking for the area of the square. So
So
you're gonna,
then I do 12 square root 2 times 12 square root 2.
yes,
All right, then. And that will give me 24 square root 2.
you're squaring. So it's 12 squared is
Oh,
144.
144 times 2, which will be 288.
280. Good job. All right, we're gonna go ahead and stop